exponential equations with the one-to-one property. Solve the following exponential equations using the one-to-one property. So here we have 4 problems that we'll solve using the one-to-one property for exponents. The one-to-one property states that if we have a base that's greater than 0 and not equal to 1, if we have b to the m is equal to b to the n, then m is equal to n. So one approach is to make our bases equivalent. If our bases are equivalent, then we can equate the exponents. So here we have 2 to the x power. So I want to try and rewrite 8 with a base of 2. So I'll write down 2 to the x, and I'll give this some thought, and I know that 2 times 2 times 2 is 8, or 2 to the 3rd power is equal to 8. So what I've done is I've just replaced 8 with 2 to the 3rd power, because 2 times 2 times 2 is equal to 8. So now that the bases are the same, I have a 2 here and I have a 2 here, I can use the one-to-one property for exponential equations, which states again that if the bases are the same, if I have b to the m is equal to b to the n, then I can equate the exponents. And so we have x is equal to 3. So I'm going to apply this idea to the next 3 problems. The goal is to try and get equivalent bases. For problem number 2, we have 5 raised to the 2x plus 1. On the right-hand side, we have the value of 125. So I'm going to try and rewrite this with a base of 5. So I know that 5 times 5 is 25, times another 5 is 125. Or 5 to the 3rd power is equal to 125. So I'm going to replace 125 with 5 to the 3rd power. Now that the bases are the same, I can equate the exponents and solve for the variable. So using the one-to-one property, I have 2x plus 1 is equal to the exponent on the right-hand side, which is 3. Now I'll solve for x by subtracting 1. So we have 2x is equal to 2. The next and last step will be to divide both sides by 2, and we find that x is equal to 1. For the 3rd problem, I need to address the exponent on the left-hand side as well as the exponent on the right-hand side. So the first thing I'd like to do is to consider the negative. I somehow want to modify the problem so that I have a positive exponent. So what I can do is I can take the reciprocal of what I have in parentheses here, the 1/3. The reciprocal of 1/3 is 3. And I can change the sign on the exponent. So I have 3 raised to the 2x. So the base here is 3. The power or exponent is 2x. On the right-hand side, we have 27, and I'd like to try and rewrite that with a base of 3. So 27 is equivalent to 3 times 3, which is 9, times 3, which is 27. Writing 3 times 3 times 3 using exponential notation, we have 3 to the 3rd is equal to 27. And so I'm going to replace the right-hand side 27 with 3 to the 3rd. So now I have a base of 3 on the left-hand side, and I have a base of 3 on the right-hand side, so I can use the one-to-one property for exponents and equate the 2x and the 3. Doing so, we have 2x is equal to 3. Divide both sides of the equation by 2, and we find that x is equal to 3/2. For the fourth and last problem, both the left side as well as the right side have the base of e, which is also the natural base. So I can go ahead and just equate the exponents, use the one-to-one property, since the bases are already equal, and I have 3x plus 1 is equal to 5x plus 7. Solving this for x, I can choose to collect like terms with the x's on the right-hand side or the left-hand side. It doesn't make a difference. I'll go ahead and subtract 5x from both sides of the equal sign. On the left side, we have 3x minus 5x, which is negative 2x plus 1 is equal to 7. Collect the constants. Subtract 1. We have negative 2x is equal to 7 minus 1 gives us 6. Divide by negative 2. And x is equal to negative 3.